What's up, guys? This is Lance English for Biochem TV, and today I'm going to show you how to do a two-step unit conversion problem using dimensional analysis. So for our first example, we're going to convert 9.9 micrometers into kilometers. So let's give this a try. So we're going to start with what we know. So we know we have 9.9 micrometers. So now we're going to start by converting that to our base unit for length, which is the meter. So we have micrometers at the top here, so we want micrometers at the bottom here. So that means we need meters at the top. So looking at our conversion table over here, we see that there are 10 to the 6 micrometers for every 1 meter. Okay, so now we can go from meter, our base unit, to kilometers. So we have meters at the top, so we're going to want meters at the bottom this time, which leaves us with kilometers at the top. Look at our table over here, we see that there are 10 to the 3 meters in every 1 kilometer. So now we can cancel out things that appear on both the top and the bottom. So we have micrometers at the top, micrometers at the bottom, meters at the top, and meters at the bottom. Okay, now we can multiply through and we get 9.9 km at the top, and we have 10 to the 6th times 10 to the 3 on the bottom. Okay, so when we have exponents like this, we usually want to combine them if we can. Since we have the same base, we can combine them. We can multiply them together by adding the exponents. So we have 9.9 km over 10. 6 plus 3 is 9 over 10 to the 9. Okay, so we usually don't want to leave an exponent in the denominator, so we're going to move that to the top. So you can move it to the top by changing the sign of the exponent. So we can change this from 10 to the positive 9 to 10 to the negative 9. So let's try that. We get 9.9 times 10 to the negative 9, since we flipped it to the top, kilometers. And that should be our final correct answer in strict scientific notation. Okay, so let's try another one. And for this one, I want you to give it a try yourself first. Pause the video and then come back and see if you got the same thing as me. Okay, so for this one, we're going to convert 16.1 milliliters to picoliters. So this one is a volume problem. So same as before, write what we know. And then we're going to start by converting that to the base unit. So our base unit for volume is the liter. So we have milliliters at the top here, so we want milliliters at the bottom and the liter at the top. So looking at our conversion table, we see that there are 10 to the 3 milliliters in every liter. Okay, so now we can go from our base unit to picoliters. So we have liter at the top, so we want liter at the bottom now. And looking at our table, we see there are 10 to the 12 picoliters in every liter. Okay, so now we can cancel out what appears on both the top and the bottom. So we have milliliters at the top and the bottom. We have liters at the top and the bottom. Okay, so we can multiply through now. So we have 16.1 times 10 to the 12 picoliters divided by 10 to the 3. Okay, so similar as with multiplication, when you're dividing exponents with the same base, you keep that base and you subtract the exponent. So let's try that. So 16.1 times 10 to the 12 minus 3 is 9 picoliters. Okay, but we want our answer to be in strict scientific notation. So that means this number needs to be between 1 and 10. So to do that, we got to make this number smaller. We got to move the decimal place over one spot to the left. So that means we got to increase our exponent here by 1. So that leaves us with 1.61 times 10 to the 10 picoliters. And that should be our correct answer in strict scientific notation. So thank you for watching, and now you should know how to do a two-step unit conversion problem using dimensional analysis, and I will see you guys next time.